Hello, we are API4, a group from Section 2 of Real-Time Software Engineering. In this video, we're going to be discussing the completion of assignment 2, which focuses on the RoboCar project. We'll explain the various aspects we dealt with in preparing ourselves for the ultimate project, which was participating in a RoboCar competition. Let's start by introducing our group members. My name is Muhammad Humi Zaid Idris, and I'll be joined by my friends Aldi Priya Bagus Ananta, Mahfoud Khairi Amron, and Rafi Atala.
During the briefing for the RoboCar project, we learned about the software and hardware components involved. First, let's discuss the software. Following the provided instructions, our group used the same software as everyone else, including AVR Studio for code editing and building, Arduino for implementing ideas and controlling motors and sensors, and lastly, command prompt to embedding the code. Moving on to the hardware, we primarily use two things, our laptops and the provided RoboCar. For our laptops, we simply use basic Windows laptops to run the necessary software and transfer the code to the RoboCar. Working with the RoboCar was a unique experience for us since as software engineering students, we hadn't worked extensively with robotic hardware before. The RoboCar featured three sensors, a line sensor to detect a track line, a light sensor to detect light, and an obstacle sensor to identify any hindrance. We scheduled two lab sessions on June 16th and 22nd. Before our first session, our group prepared ourselves by studying and briefing slides and downloading the required software. However, we faced a challenge when we realized that we needed a Windows-based operating system for the software, which meant we had to download it again on a different laptop since our initial attempt was on Mac. Despite this initial setback, we managed to resolve the issue and updated the code syntax to embed it to the RoboCar. During our first session, we faced challenges with software integration. We had to download the software again on a new laptop. Updating the code for the RoboCar was necessary due to file directory issues. We didn't have enough time to make necessary code adjustments, resulting in an unsuccessful first lab session where the RoboCar couldn't complete the first obstacle. Fortunately, our second session went better. We found solutions to the code problems and made rapid changes. On our first try, the RoboCar successfully completed the first track. We continued updating the code to tackle the second track, but unfortunately, the RoboCar couldn't finish it entirely, managing to cover about 3/4 of the track. More details about the code will be explained in the next part.
Hello, my name is Muhammad Rafetala, and I will explain our code that we created for the RoboCar. So we got like 5 tasks. The first is task start, then check collide, control motor, navigation, then task light. This is the priority for each of them, as you can see here. Then the check collision task is to check whether the proximity sensor has detected an obstacle. If there is, the function will update the myrobot.obstacle in the myrobot structure. They contain the speed, the obstacle, the tick light, conjunction, and checkpoint. So it will change the obstacle to 1 and checkpoint to 1. Else it will change the myrobot obstacle to 0. It means there is no obstacle. We change the period to 5 milliseconds since it says the processor of the RoboCar itself quite fast, so 5 seconds is quite enough to apply in a real time and fast-paced real time. Next is the control motors. The control motors itself is the function that will determine the speed of the robot. It will refer to the myrobot.speed and also the myrobot.l speed that consists in the struct myrobot before. Then apply the robomotor speed, the speed for the left wheel and the right wheel according to the previous declared variable. The period for this function is around 20 milliseconds because the last thing that will be updated after the collision has been checked and the other required function has been checked first. Next is the navigation. So this is a no line to detect whether there's a line or not. The first one is for my robot obstacle. If there is an obstacle, it will declare no line to 0. Then the speed is 70. Then the right speed is 70, and the left speed is 30. So it will turn right. Next is the my robot detect light. If it is a light has been detected, the robot will move forward in our coding. Next is the two. It mean it only detect one dot in the middle between the 3 line sensor and will go forward with a speed of 60. Next is the 1 and 3. When it detects 1, it will go right, but it will go fast by the right speed will be -50 and the left speed will be 50. But in the 3, it will go a little bit slower. The right speed will be -30 and the left speed is 30. Next is 4 and 6. It's the same condition as the 1 and 3, but this is for the left. For the 4, it will be the one that has 50 and -50, and 6, the one will have 30 and -30. 7 is where a junction will be detected. So in our code, we prefer for the robocar to go to the right. So, but it will turn slowly. So we created that the right speed is -30 and the left speed is 30. The next one is 5. The 5 means that only the right and left of the between 3 line sensor is detected. We prefer it and we code it for it to move forward but a bit slowly. So we give both the right and left speed 30. Lastly, if the robo line sensor detects 0, we got a condition in it for the null line. So if the sensor detects 0 for like a couple of time in our condition like 500, since this function will be function every 25 milliseconds, when it reach 500, it will move, it will reverse, move backward. But if it equal or more than 700, it will stop. Next function is the check light, is to detect whether there is light detected, a shiny light detected. It's around 60. It will change the my robot detect light by 1, and else it will change the detect light by 0. The function test start is where all the test is called and apply to. You get a 5 millisecond period, 5-second period. And lastly, the main function is where all the task start, the other function that and the default setting is being applied to. I think it's all that I can explain regarding our code. Thank you.
Now I'm going to be discussing about the day of the competition. So on the day of the competition, our group was assigned the 38th order. We had to wait for some time before getting the chance to test our code on the robot run complete. Since we were on the 38th, we were like one of the last groups there were, and not only that, we only had a little time to test our code on the robocar before we competed. The competition was a thrilling experience as we got to challenge our code against other groups and have fun in the process. Although we weren't able to complete the obstacle, we were still able to score 30 points, which was pretty good and commendable considering the challenges we faced during our lab session.
Now let's talk about positive and negative aspect of Robocar project. The first one, the rapid progress of the during the lab session. The second one, successful completion on the first track on the first attempt. The third one, enjoyable experience during the live session and also during the competition. The last one, scoring 30 points despite not completing the obstacle. Now let's talk about the negative side. On the negative side, we have initial difficulties with integrating the software due to operating system compatibility. The second one, insufficient time for code adjustment during the first lap. The last one, inability to complete the second track during the lab session.
In conclusion, our group API4 dedicated significant effort to complete assignment 2 and participate in the RoboCar competition. We faced challenges along the way, such as software compatibility and time constraints, but we managed to make progress and enjoy the competition. Although we couldn't overcome all obstacles, our achievements and the experience gained were valuable for our growth as software engineering students.